Internet of Things and its application. So today is going to tell about a definition of IoT and so what are the advantages and disadvantages. So this what is first we want to know about what is IoT. So IoT is nothing but Internet of Things is the network of smart physical objects. So you want to be physical objects by means of devices and vehicles and buildings, etc. It is embedded with the sensors and actuators. So this computation unit you want to be memory unit, power source and network connectivity. So which enables the physical object to collect the exchange the data, so analyze the data collected to extract the new insight and respond accordingly. So what is the goal of IoT means? To connect the unconnected that is things or objects that were not supposed to be connected to the internet. So IoT it did the technology, so transition in traditional computer networks. So in this technologies means it will covers the unifications of technology, embedded systems, low power and low rate networks, internet, big data, data analytics, cloud computing, edge intelligence, software defined networks, network and data security, etc. So the next alternative definition of that one is the IoT, that is Internet of Things, is the network of physical objects that can contain embedded technology to communicate and sense to interact with the internal states or the external environment, that is defined by the Gartner research. Next, a brief history of IoT. So in this IoT, the term IoT was likely coined Kevin Aston of the PG, that is P&G, Procter and Gamble, later MIT Auto ID Center in 1999. In 20th century, the computers were brains without sensors. They only knew what we told them. Now in 21st century, computers are sensing the things for themselves, that is defined by the Kevin Aston. So in the early 1980s, at the Kenneth Mellon University, a group of students created a way to get their campus Coca-Cola vending machine to report on its contents through the network. So in order to save them to the truck, if the machine was out of the Coke, that is the that particular machine that will be intimated for that one. So in 1990, John Romkey, developer of the first TCP/IP pack for IBM PC in 1983, connected a toaster to the internet for the first time. In 1991, a group of students at the University of Cambridge used for webcam camera to report the coffee available in the computer labs, that is coffee pot. At the beginning of the 21st century, LG Electronics introduced the world's first refrigerator connected to the internet. So next one, in this chart, how the popularity in the IoT. So in the 1990, internet is used for connecting digital access, that is email and browsers and searching the browser search. Next, in post 1993, it is used to network economy, that is digitalized business, that is e-commerce as well as the digital supply chain and collaborations. Next one, in early 2000, immersive experiences, that is digital interactions, that is social, mobility, cloud, video. In 2010 onwards, IoT is used to digitalize the world, connecting the people, process and data and things. So this is the evolutionary phases of the internet. So here, benefits of internet, the IoT, that is we have a Internet of Things, that is automation, predictive maintenance, process efficiency improvement, cost reduction, improved new insights, adaptability. See these automations, that is missions can assemble the parts with the more precision and speed, resulting in few errors during the assembly. There will be precaution. Robots can rapidly, very rapidly detect the faults that may not be detected by the human eye. So next advantage is predictive maintenance. The continuous monitoring of the systems and processes and to identify the key indicators of the problems before they result in downtime or system failures. Next advantage is process and efficiency improvement. That is, process improvement is nothing but it will be every aspect of the operations on the bottom line that will be integrated. And next one, another advantage is cost reduction. So when an organization can improve the system uptime, automate process, reduce the risk of failure, and gain the insights that support the better decision making and reduce the resource usage, the results is efficiency and cost saving. So next benefit is improved in new insights. IoT systems often act as the eyes and ears on remote, hard to reach or widely distributed equipment process. Next one, adaptability. So the ability of to adapt the new business requirements, the customer needs, and changing the conditions or scale of deployment in response to business growth or customer requirements. So next one, we want to discuss comparison with the IoT and WSN. WSN in the meaning of it is defined as wireless sensor network. WSN refers a group of specialized dedicated sensors with the communication infrastructure. It is primarily used for monitoring and recording the physical environment conditions like temperature, sound, pollution, humidity, and wind, and so on. It is designed for the acquire, process, transfer, and provide the data information extracted from the physical world. So in WSN, that is wireless sensor network, it is not a direct connection to the internet. Instead of the various sensors to connect the some kind of the router or central node. So WSN, it is a resource constrained sensor nodes and combined with the wireless network, and they will be connected as the nodes and gather some data from sensing the environment. In the IoT purpose, we are going to use that WSN as well as the internet and application and cloud computing, data analytics, etc. These are all grouping together, that is a IoT. Here we have small differences between the IoT and the M2M, that is given as a table. So M2M is machine to machine. It is a concept where two or more systems that will be communicate with each other without human interactions, that is using the either wired or wireless mechanism. So basis of the IoT connection type is, that is a IP network, that is Internet Protocol Network, that is using the various communication types. In the as well as the M2M, it is mainly used for point to point. Next, communication protocol. It is a that is IoT is IP based protocol. M2M proprietary, that is own protocols. Next, internet. In the internet IoT, internet connection is required, and M2M not dependent on the internet. Data sharing. IoT data is shared with the other application if required. So in M2M, data is shared with only the communicating parties. Next, Open API. API is Application Program Interface. It supports Open API integrations as well as the M2M. There is no support for Open API. Scalability. In IoT, more devices, more scalable due to cloud-based architecture. In the M2M, we have limited devices, less scalable than IoT. So examples of IoT is smart home, smart wearable devices, etc. In the M2M, it is a sensor telemetry and ATMs in bank. So here the growth of IoT device, that is we are not included the non-IoT as well as the IoT, that is a comparison is 2010 to 2025, that is given in the differentiation, how it will be growth rate will be given that one. This is the IoT analytics prediction of that one. So here we want to be discuss IoT and its application. What is the main concept IoT and web technology? We have the main two key concepts in the IoT as well as the web technology. The both can be together. That is a simple explanation is given here. So IoT is Internet of Things. It is refers to the network of physical devices, vehicles as well as the appliances or any object that is embedded within the sensors, software and other technologies to connect and exchange the data over the internet. The devices can communicate with each other and be controlled remotely, making every object smart. So examples of IoT, that is smart home devices, that is for example smart thermostats, smart lights, wearable devices, for example fitness trackers and connected cars, that is a GPS navigation system, self-driving capabilities. These are the examples of IoT. As the part of web technology, so web technology is nothing but it is a tool that is and standards that allows to websites and web application to function. It includes the both development of the front end, that is the user whatever the screen that is in front of the user can watch the screen, that is called as front end, as well as the back end where it will be stored the data, that is a processing, that is the server side. So we have a client and server technology. So these technologies to enable the users to access the interact with the services on the web, that is a web technology. So for example, some of the examples of web technologies, we are going to construct the web pages using of HTML, CSS, that is hypertext markup language, that is a static language. CSS is you want to design the structure of the page, that is a language is used to structure and style web pages. Next one, JavaScript. JavaScript mainly used for the validation purpose. You are whatever they giving the information, providing the information, they will be checking and giving the right decision, that is the validation. That is a program language used for interactive features. Some of the features also added using of the JavaScript. And also we have a web service. So whatever the request is given, the response will be given from the server. That is a client request and response from the server. That is we have using the platform of the host websites, that is manage the user request, that is Apache Tomcat, IAS, PWS, WebLogic, WebSphere, like that we have so many web servers will be there that will be responsive of that. And for example, you have a google.com, we are giving that typing of that particular website address, that URI address can be linked to the server. They will be what you are going to request, that a particular home page will be displayed. So after giving the actions, that actions will be responses from the particular web servers, whatever they created in the hosted in the web servers. So how IoT and web technology work together? So IoT devices often use the web technologies to transmit the data to a cloud platforms of user interfaces. For instance, data from the smart thermostat could be viewed and controlled via using the web applications or mobile applications. So leveraging the web technologies like we are using the API, application program interfaces, HTML, CSS and JavaScript. So these are the technologies using of the whatever that IoT, you are extract the data and it will be stored to the edge computing, using of edge computing. The particular cloud platforms can be using, and we can design the using of this particular web technology, that is HTML, CSS, JavaScript. So in this summary, IoT is connecting the physical objects using of the internet, enabling them send and receive the data. Web technology, that is a creation and functioning of the websites and web application that allow users to interact with these connected devices. Next one, the IoT has significantly evolved, expanded as a shaping aspect the daily life, businesses and industries. Today, IoT refers to the interaction with of everyday objects to the internet, allowing them to collect and send and receive the data. It has moved beyond the smartphones to include the wide range of application across the various sectors. So here are some of the key features of the IoT today. That is the connectivity everywhere. So that is we have devices as well as the network. The particular devices, IoT encompasses everything from household appliances like refrigerators and thermostats to wearable devices like that is a fitness trackers and even industrial machines to in factories. In the network as well as the network, the devices connected with the wireless communication through the some of the technologies as Wi-Fi and Bluetooth, Zigbee, 5G and LPWAN, that is a low power wide area network. These are the networks we are going to connecting of that one. Next, we have a data collection and real-time insights. So IoT devices are embedded with the sensors that collect the physical world. The data is sent to the cloud platforms or local servers where it is processed or analyzed. And the real-time monitoring, that is IoT systems provide the real-time insights such as monitoring of wearable or tracking the particular inventory levels, warehouses, and third thing is data analytics. That is a large amount of data will be available collected from the IoT devices. We will analyze using of big data to provide the predict future trends. That is we have elaborately, efficiently. We want to be data driven. Whatever of customer requirement, we will provide it for that one. So next one we have automation and controls. That is we are going to use that smartphones, industries, industrial IoT. Smartphones means IoT allows users to control home systems remotely, adjusting the controlling the of lights as well as checking the security cameras using of IoT. And in industrial IoT, that is we can use that key component of automation of industries. So that means manufacturing, logistics, that is the tracking of that one. So how it will be manufacturing, any defects can be, that is defects can be identified. That particular devices can communicate with the machines and streamline production and supply chains. Next one, healthcare. In health, IoT enabled devices can track the patient conditions without interaction of the doctors. They will be precaution to the doctors. That will be IoT is monitoring and helping to prevent the emergencies. So next, some of the applications of IoT today. That is as well as the smart homes, health, care and wearables. And here some of the diagrammatical representation where IoT is defined. That is a wearable technical devices, that is we are going to use that smart watches that will be using of tracking of information, that is through the apps, mobile apps. And we have a refrigerator that will be controlled, will be sensors using of that one, they can be sensing of information. Next one, healthcare, the patient's information, and as well as we have industry automation, how industry is going to run that one, that a particular IoT can be sensing of that one. Here smart cities and agricultures, that is also IoT based. IoT also enables remote patient monitoring where doctors can track the health details and the prediction of how patients is improvement, those things will be better to help that one. Smart cities. In cities, in the using of IoT, usages, resources, services more effectively. For example, traffic lights and street lights can be adjusted based on the traffic condition to reduce the congestion. Waste management can be optimized by the IoT sensors. So if the garbage bins, that is the dustbins will be filled, that will be indicated to the particular authorities, and there will be indication of that one, precaution of that one, unnecessary pickups, reducing the unnecessary pickups. Next one is the agriculture. In the IoT, increasingly in farming, soil moisture, and we have weather conditions, and smart irrigations can automatically detect and giving the suggestions the timely oriented usage. Next one, in the industry and the manufacturing, that is the industries, we have industry settings, we have a maintenance of machinery, reducing downtime and improving efficiency. We can using of IIoT, industrial IoT. Sensors in equipment send the data to the cloud systems to predict the failures before they occur. So next one, we have supply chains can be benefit from the IoT enabled tracking as well as allowing the business to monitor the goods real time from production to delivery. Here we have a global IoT market shares can be is diagrammatically pie chartly they can be given that one. So retail market less than 2% IoT use. In the smart utility and the energies, that is a 4%. Industrial IoT, that is a 24%. Healthcare 20%. Smart cities 26%. Personal health 20%. Connected cars 7%. Wearable, that is wearable devices, that is 3%. Smart homes, that is 14%. Here the smart home. In this smart home, so how IoT, the different devices, what are the activities in diagrammatically, that is we have in this diagram can be showing up that one. Here we have a activity detector, that is we have a living rooms, bedrooms, bathrooms, etc. They can send the data periodically. Next we have a telecare basement, that is collect data from the various detectors, mobile networks, and health environment sensors, that is a transmit capture the data to the telecare server through the base unit. Here fire related gas detector, that is transmit detected data when an event breaks out. So help trigger, that is press the button for help from the anywhere or around the home. You can be easily emergency, that is alarms can be tracking that tracking the particular persons. They will be precaution of that one. Next, pedometers tracks the movement data inside and outside the home. This is smart home. This is the industrial IoT. So here industrial IoT we have the cloud server is connected through the HTTPS. We have a browser, can have the device management, data storage and data visualization, admin, all the using the process we want to be giving that one. We are using that some of the IoT gateways, that is we have a Microsoft Azure, AWS Green, Gas, data aggregation, data logger, WWAN, WLAN, VPN client, the particular environment, that is we are interaction with the mission. So we have some of the protocols can be how equipment is sensorily, they will be connected and transmit the data from one place to another place. This diagram will be showing off that one. Here the connected cars. So while we have every car they can have that sensors tracking of that one. They can have the sensors using of some of the protocols. They can have the nearest cell phone towers that will be centralized data, the particular magnet data, value added network that will be controlled to the cloud system. That is we have using of either 4G network, LTE or 5G or whatever the networks we want to be connecting and tracking the information about the mobile. That is, we have a that is for car tracking information. So here one of the self-driving car is given that that is developed by the Google's. That is a self-driving without human interaction. They can have the sensors. You can tracking the path. They will be showing off that one. Next, challenges facing of IoT today. That is, my challenges means in face of we have security and privacy. So that is whenever we are going to use that internet means that is a public. So we want to be giving the security and the privacy, interoperability and power consumption. These are the nowadays challenges facing the IoT today. So in the security and privacy, IoT devices are vulnerable to cyber attacks due to their constant connectivity or to the internet. The lack of sufficient security features making them potential entry point for hackers. So data privacy is a significant concern. IoT device can collect the vast amount of personal information. Ensuring the secure data transmission and storage is critical. So interoperable. Different IoT devices often use the different communication standards as well as which can make it difficult for them to work together. They can have the standardizing protocol and platforms is the ongoing challenge. With proper integration, users might find it cumbersome to manage the devices from the different manufacturers. Next, power consumption. Many IoT devices run on batteries and power consumption is a crucial concern, especially for remote and outdoor devices. Research is ongoing to create the energy efficient devices that require the less power. So data overloaded. The massive amount of data generated by the IoT device can be overwhelming. That is, we have how to manage that one, how to analyze that one. This data effectively requires the robust system and advanced analytical tools. That is, we are using that big data, machine learning algorithms can be using of that one. Regulations and standards. So as IoT expands, there is a growing need of clear regulations and standards will be created for that one to ensure the safe and efficient and ethical use of these technologies across the industries. Here, the main challenges can be given in this one. Sensors, we have a limited resources and limited type of sensors. In the scale, millions of devices are connected from the IoT and privacy. Which personal data to share with whom? How to control that one? Next, security. So what are the things becomes to be connected? So security becomes complex for that one. And the low power network, that is devices should remain connected to the internet for the years. High network latency. Next, big data and data analytics. That is, we have a massive amount of sensor data, different sources and various forms. Exact intelligence from the heaps of data. Interoperability. Various protocols, various architecture, unavailability of standardized platform, different technology leads to the interoperability issue. Recent IoT standards are minimizing this problem. So next, future of IoT. That is, future of IoT is 5G, 6G connectivity and edge computing and artificial intelligence and IoT. So these are the future IoT. The arrival of 5G technology will significantly enhance the IoT capabilities by providing the faster speeds and lower latency and improve reliability. This will make real-time data exchange and automation even more seamless. Edge computing. In the edge computing is nothing but where data is processed and closer to the resource on the device nearby the servers will help to reduce the latency and allow the more efficient real-time decision making. Next, AI and artificial intelligence and IoT. The integration of artificial intelligence with IoT will enable smarter decision making. These IoT devices can combined with the AI can automate the task, predict the outcomes, and improve the efficiency across the net sectors. So next one, time for convergence towards the IoT universe. The IoT is rapidly evolving and we are heading towards the future. That is, everything is connected. That is, we have IoT universe. In this future, IoT will connect the not only homes and also businesses, the entire cities, industries, as well as the systems. We need that convergence, that is a communication, refers to the integration of various technologies. We need such as in artificial intelligence as well as the 5G networks and cloud computing that together enable to IoT to reach the full potential. The convergence is pushing us to closer to world where everything from everyday objects to complex systems communicate seamlessly to create smarter environments. Next, IoT vision. This is the what is the vision of IoT in the future means that is a hyper connected world where the devices can real time to improve the efficiency and decision making across the all sectors. For example, imagine that one, smart homes, smart cities, healthcare, industry. So these are the future visions of that one. Smart homes means we have the refrigerators, thermostats to adjust the levels of that one automatically. And smart cities, traffic lights, waste management, energy systems will become more efficient for using of IoT data. Healthcare, patients will be monitored and the doctors will have the real-time data to make a better decisions. In the industry's purpose, machines in factories will predict the maintenance needs and making the production more efficient and cost effectiveness. In future, IoT will create the intelligent system that enhance our daily lives and make the world more sustainable and efficient. Here, the future IoT strategic research and innovations directions is we have improving the connectivity, next data security and privacy, and artificial intelligence and machine learning integration. These are the research peoples also can be doing of it. Next, edge computing and standardization and interoperability, sustainability. Next, IoT applications. This already I defined that IoT applications is used in home automation, energy management, healthcare, remote monitoring, and telemedicine. Here we have a diagrammatical reference, smart healthcare medical application. We have some of the devices, how it will be, the using of Bluetooth, they will be sending the data of gateways. The particular data will be collected to the particular routers, they will be collecting the data. So as well as we have different equipments of medical equipments will be connected using of Bluetooth device. So next, smart cities, there is traffic management, waste management, public safety. In the industrial IoT, predictive maintenance and supply chains and logistics, agriculture, precision farming, livestock monitoring. These are in the smart cities. In this diagram, this picture we having IoT is where are the places that will be traffic management, smart health, intelligent shopping, public safety, gas and water direction, smart energy, water equality, quality and smart parking, electric vehicle charging and waste management, smart street lights, smart home, smart building, electromagnetic emissions, open data, air pollution, smart environment, education, all those things in the covers in the smart city using of IoT devices. They want to be sensors, they will be collecting the data. In the smart agriculture, means we have whatever that farmers agricultures, they want to be pest control, water supply control and crop monitoring application using of how crop can be monitored and soil moisture monitor, plant health monitor, livestock monitor, and climate monitor, vehicle monitor. These are the without human interaction. We have it. That is a sensors. You want me to that one. The particular application can be what are the data will be collected and stored into the IoT cloud. This is the future smart agriculture with the modular IoT gateway. So this is the livestock management. Here we have a different and that is a animals, that is ear tags will be where the particular network that is will be connected to the remote. So without human, they will be tracking of animals using of tags, ear tags. Here we have a mesh nodes, that is we have a in the future internet technologies. So this will continuous in the 5G and beyond, edge computing, artificial and machine learning, and we have infrastructure and networks and communication. The backbone of the IoT is lies between the infrastructure, network and communication. Infrastructure is nothing but there is a robust and scalable infrastructure is required to support the growing number of connected devices and data they generate. This includes the data centers, cloud platforms and communication networks. As well as the networks, we are using that LPWAN, that is a low power wide network, that is like LoRa, NB-IoT and Sigfox are designed for the IoT devices to require low power, long range of communication, and also simultaneously Wi-Fi and Bluetooth are commonly used to short range and high speed communication homes and businesses. And communication standardization communication protocols like MQTT, COAP and HTTP are the more essential seamless interaction of between the devices and platforms in IoT ecosystems. Next, process and data management. Data management is nothing but you have a data collection and storage, and how you want to be data storage, how you want to be data analytics. So data collection and storage is IoT devices can massive amount of data will be collected using of sensors, the particular which must be securely stored and efficient managed. The cloud platforms offer scalable storage solutions, data processing. We are in this data, whatever the data is collected from the data collection, so we will be processed in real time, that is using of edge computing. So in the cloud, deeper analysis such as we have predictive analytics and machine learning and artificial intelligence application can be used to process the data. In the data analytics, IoT generates the valuable insights that need to be processed and analyzed to support the decision making. We can using that big data analytics helps to convert the raw data for actionable insights. So here security, privacy, trust. So this is the IoT device mainly we are using of data will be shared. We want to be need for security, privacy and trust of that. So IoT devices lack of strong security features, making them vulnerable to cyber attacks. That is encryption, secure communication protocols and device authentication are essential to protect the data from unauthorized access. Privacy. IoT devices often collect the sensitive data, personal data, that is the health data from wearables and locations data from the connected cars. The proper data encryption and anonymization are essential to protect the user privacy. Trust. So we want to trust for IoT systems to sharing the that is widely adopted. We are using the transparency compliances with the data protection laws. So we have a clear consent regarding data storage. So next one, device leveling energy issues. In this we have power consumption, energy harvesting, low power protocols. In this power consumption, so many IoT devices rely on batteries. So So energy harvesting and low power protocols. Thank you.